Alright, so this is your review worksheet, and then this we will actually graph together on Monday, so when you turn it in, you don't have to do this section, okay? We'll do that together. These are just some fun, unusual polar graphs, so you can see all the different things that they can make. Okay, so you need to do all of page 1. These are the ones on polar paper. And then when you get to 9, I want you to remember a few things. So we're going to look at part of that together. So it says determine the polar coordinates for each of the given rectangular coordinates. And you can use either degrees or radians. Round decimals, you're going to have lots of decimals here. You don't have to use the exact values. So I said remember to pay attention to the quadrants. So something you want to make sure that you're looking at is 512. In a rectangular coordinate, what quadrant would that be? Okay, so your final answer should be a value that ends up in quadrant 1. This one is going to be what? Yep, quadrant 2. Okay, so what are the equations that we use to convert rectangular to polar? So what do we use to convert? What are our two equations? Yep, so the tangent of theta equals y over x. That's how we're going to find theta. How do we find r? R squared equals x squared plus y squared. Okay, so for this you will likely want to write your work down on another sheet of paper. That's perfectly fine to keep this looking nice. Just turn in your work as well, okay? So if you are finding your r squared, you have 5 squared plus 12 squared, and then you're going to be taking the square root. Okay, so remember, like I said, they don't have to be exact values. This one just happens to be one. So whenever you're writing out your polar coordinates, you want your r theta in your brackets. Okay, and then will you guys calculate that for me? Well, and for you. This is actually a Pythagorean triple. 25 plus 144. Yep. Okay, and then for your tangent of theta, okay, you're doing y over x. So this would be 12 over 5. How do you find that? You have to do what? That's not it. You have to find the inverse. So to find theta, you're going to do the inverse of 12 over 5. Alright, so will you guys do that on your calculator for me? Yeah. Okay, let's look at some of these numbers. See what's happening here. So are you going to have to find a bunch of different r's here? Oh, yeah, you do, because you have to find the r and your theta. Okay, so when you do the, make sure you're doing the tangent inverse and not the tangent, okay? Alright, so what decimal did we get? 1.18? Okay. And then, were some of you in degrees? Okay. So I said you could do either one. I think radians is going to be the most common. So is 1.18 in quadrant 1, and how do we know? Yep, so we know quadrant 1 goes up to half a pi, which is 1.57. This is 3.14, 4.71, a full circle is 6.28. Okay, so when you get that value, when you're writing it as r theta, you would write 13, comma, 1.18. Okay, and then you're going to put them in brackets. Okay, now, I know that looks like a lot, but look, this is negative 5 and 12. If you find r squared, if you do negative 5 squared, aren't you going to get the same thing? Yeah, so 25, so this is, your r value is still going to be 13. The only difference is now when you're doing your tangent inverse of 12 over negative 5. Let's find out what that is. So this was A, this is B. Okay, and then what did you get as your value? Negative 1 point. Okay. Now, what quadrant is this in? It's in Q4. Okay? So I need to find the one that's in Q2. What do we know about all tangent values? It's pi away. I'm only 1 pi away. What song is that? Oh, One Call Away, Charlie Puth, right? All right, so now you're pi. Okay, so if you want to find out what that is, all you have to do is add pi. And that will put you in quadrant 2. Okay, and then will you guys tell me what you get when you calculate it? 1.96? Yep, good. Okay, so again, your R is going to go first. Okay. And then you are in quadrant 2. Now look at this one. What quadrant is this in? So positive, negative is in quadrant 4. Didn't we just find the one in quadrant 4?
Yeah.
Yep, so you can just leave it like that. So 13, negative 1.18. Okay? So just like I did, like where I wrote down the quadrants, that's what I would do. And again, tangent is always going to be pi units away. So if you're not in the right quadrant, then you're going to add pi. And that should put you in the right quadrant.
Is the quadrant for the original quadrant?
Yep, yep. So when you're converting from rectangular to polar, these are telling you the same place in space where you have these. So if it's in quadrant 4 in polar, it should also be in quadrant 4. Okay? And then this is what we did in 8-1. So you're using your two different representations. This is where if you're given something, you add 2 pi. The opposite, you do plus 2 pi. So the two different representations is going to be R is 0 and R is less than 0. Your two different places. And then that one, once you graph it, you can use your table to do it. Okay? How's number 8 going? Should we write down the equations, or are you pretty good at those? So for rectangular coordinates, that's where you use x equals r times the cosine of theta, y equals r times your sine of theta. And then that will give you your point. That's xy. Okay?